Okay, this video is going to be made to help you review sort of solving quadratic equations. We're going to talk about 4 different methods, and I'm going to move fairly quickly. If I'm not moving fast enough, and again, you're good with one of the methods, like say factoring that we have on the screen here, feel free to scroll forward to the next method. But again, we are going to discuss 4 different methods: factoring, solving using square roots if the problems are a little similar, or simpler, I should say, the complete the square method, and the quadratic formula. And we'll talk along the way about how kind of where the advantages are here and there of each one. Factoring is a great method. It's usually a pretty fast method when you can use it. The problem in the middle is what typically people think of when they think of a factoring problem. Our goal is to try to take this thing apart, because we have a nice rule in math that basically just says if two things are multiplied, right, equal to 0, then one of those two quantities needed to be 0. So if I can separate x squared minus 10x plus 9 into 2 pieces, I could sort of separate it into 2 equations and usually make easier to solve equations. And the big thing we want to remember going forward when we think about foiling a problem, right, because we've got x probably plus or minus a number and another x, because x times x would have been our x squared here. Going forward, as far as like distributing and foiling would go, we would get to x squared minus 10x plus 9 by figuring out what two numbers are going to add, right? That, if you're familiar with FOIL, that inside outside is going to add to negative 10x, and we're going to multiply to 9. Well, if I can think of the two numbers that do that, we're going to be in good shape here. So adds to negative 10, but multiplies to 9, I would say negative 9 and negative 1. They're going to multiply to positive 9 if you, again, distribute. And again, we're going to have a negative 9x and a negative 1x that would have added to negative 10x. Well, that means that either x minus 9 equals 0 or x minus 1 equals 0. And in that case, x could have equaled 9 or 1, right? I'm going to add that 9 to the right side and add that 1 to the right side. And basically we get our two answers. If we plug those numbers back into our equation, you'll quickly find out that those are your solutions. Now, sometimes factoring can be a little bit faster than that. Over here at the left, we've got 9x squared minus 1 equals 0. This might look like a good problem just to go ahead and solve using square roots. Maybe just add 1 to the other side and divide by 9. And you definitely could. But if you do recognize that this is what we call the difference of squares, okay, where that middle term was missing, right? Notice we didn't have an x term like we had that negative 10x before. We don't have that middle term because, again, 3x times negative 1 and 1 times 3x, those two middle terms would have added to 0. Well, in that case, that means, again, either 3x plus 1 equals 0, or, I'm going to run out of room here, but I think I can fit it in, 3x minus 1 equals 0. So either 3x equals negative 1, or 3x equals positive 1. And x could be either negative 1/3 or positive 1/3. Again, we get those two nice solid answers there. And then finally, over here at the right, it gets a little trickier if we're not equal to 0. So again, the first thing we're going to want to do is get ourselves equal to 0. Then is also that 2 out in front, that 2x squared makes things a little bit harder to do. But there is a great method called factoring by grouping. And it's a little bit weird, but you can do it. If you still want to add to the middle, much like we added again to that negative 10x, I want to add to negative 19 this time. I'm going to multiply, though, when I'm thinking about what I used to multiply just to that end term, right? We talked about multiplying to positive 9 in the middle problem. I'm going to combine the first and last terms. So I'm going to multiply to negative 66. So what two numbers would multiply again to negative 66 but add to negative 19? I'm thinking, well, probably negative 22 and 3. And again, that just takes playing with some numbers. Figure out what multiplies to negative 66. That's going to be a very narrow list. But if you figure it out and you multiply out and you add, I think those two numbers work for us. So now what we need to do is take 2x squared. I'm going to split the middle. I'm going to kind of reverse that foiling idea, only I'm going to do it sort of step by step. 2x squared minus 22x plus 3x minus 33. Notice I'm just removing that negative 19x, and I'm putting in those two numbers I came up with. Then we're going to do a little bit of simple factoring if there's anything in either of the first two parts. So 2 and x both go into both of those, leaving me with an x minus 11, and whatever goes into the next two steps. So again, looks like there's a 3 in both terms. So x minus 11 again. And if there's an x minus 11 in both the first and second half of my problem here, then one of my factors is x minus 11. The other is 2x plus 3 equal to 0. And if we split it and solve it, again, x minus 11 equals 0 means x could equal 11. And 2x plus 3, well, if I subtract the 3, that's going to be a 2x equals negative 3, which means x could be a negative 1.5 if we divide both sides by 2. And I believe those are my two answers. All right, we've been talking a while there, so I'm actually going to split this video real quick. If you're looking for more help, though, look for my next video. It'll be sort of quadratic review part 2, and we'll talk about, like I said, those other methods, solving using square roots, completing the square, and the quadratic formula. If you have any questions on factoring, though, talk to your teacher and have a great day.